Don't get me wrong. When I was your age, I was a moron.
Exactly.
We're in 8.2.
I think everybody's a moron when they're around my age now.
Oh,
That's
okay.
funny, right?
Here, you get a hold.
See the.
All right, so let's try this again. Class.
Yeah. Oh, I forgot what I was supposed to say.
Oh.
I know, like, actually, I was like.
Okay, let's try this again. As long as some people don't have their cell phone out in their face right now. All right, so let's try this again. You guys ready? Are you ready? Are you ready? Class.
Yes.
All right, not bad, not bad. We tried. Okay, but there's no feeling there. You gotta feel it.
Half the class.
Half the class. There's 1, 2, 3. Yeah, you're right. 4.
Yeah,
Yeah, it's half the class.
You went to 4 and I was like, it's already half.
I know. All right, but do you know what? I prefer the smaller classes because I think there's more one-on-one, more communication, and if you get that giant class where you can just hide in the back and no one ever calls on you.
So college lectures.
Yeah, you really don't get much out of it. You don't, and there's more personalness here. Okay, so anyway, all right, verify that this is an identity. Crap, this is a hot mess, isn't it?
Yes.
Okay, so first, let's translate it
into the identities or whatever.
Yep, translate it into algebra.
Yeah.
X, Y, and R, but in this case, my R value is always
1.
my R value is always 1. So, tangent is
Hold on. Y over X.
minus cotangent
X over Y.
all over
Y and X.
Y times X, right? So now on the bottom, yeah, I can rewrite it as fraction too, right? I would put those over 1, wouldn't I? Because those are over R. So this is Y over 1 times X over 1. Just to show the ones are not necessary there. Okay? Equals. Now up here, this mess, what is secant?
Secant.
1 over x.
Right,
So
squared.
secant squared is
1 over X squared.
1 over x squared. Minus.
So you wouldn't square the whole thing, you'd square just the X.
Okay, you ready? We are going to. What is 1 times 1?
1.
What's 1 squared?
Still 1. Oh, fair enough.
Make sense now? Okay. All right, and minus cosecant, which is
X over Y. Oh, X over Y. 1 over Y.
1 over y. Very good.
Oh, yeah.
1 over y, and it's cosecant squared, so it's 1 over y squared. Now, let's go back to yelling at your Algebra 3-4 teacher, because they all suck.
Oh, yeah.
Especially if you had me. Ugh. That guy was
It
horrible.
was the online year, too.
Oh, man. Ugh. Anyway, so fraction over fraction. This thing right here is a hot mess, right? So I have a fraction minus a fraction over a fraction. We're going to clean it up by multiplying the numerator and denominator, everything by the common denominator. So, common denominator at the top, common denominator at the bottom. What is the common denominator of the top?
Of the top? Oh, both of them, X and Y.
X and Y, very good. So it's X and Y. You zoning out? Okay, so it's X and Y. All right, so the common denominator for the whole thing down here on the bottom is 1, right? Okay, so I would multiply by the common denominator everything, which is just going to be XY, isn't it? Now, I'm going to multiply by the factor of 1. I'm going to multiply by 1. So if I multiply anything by 1, what do I get? Same thing, right? But my 1's going to look funny. So I'm going to multiply by XY over XY.
because the xy on the bottom is the same thing as multiplying y dash.
The ones. The denominator on the bottom is 1 and 1, right? So multiplied by the common denominator on the bottom, those are just ones.
Yeah.
So, there we go. So from here, I'm going to try and clean this up a little bit. So as I distribute here, what's going to happen to the x's when I do that? What's going to happen to the x's? I'm multiplying by an x, and there's an x in the denominator. It's going to cancel, right? Because I'm multiplying here, and I'm dividing on the bottom. So the x's will cancel. So that means that I'm just going to have y times y, which is y squared. Minus. I could put it over 1 if you want. We could do that. But it's not going to be necessary. Now, let's do it again. Over here. Now this time, I'm multiplying by xy, and on the bottom, the denominator, there's a y. What's going to happen to the y's?
They're going to cancel out.
Cancel out.
X squared.
And it's going to be x times x, so it's x squared. So, like I said, if you want it over 1, you can. It'll be fine. But I'm going to get rid of those to make my thing a little bit easier here. Now let's do the same thing on the bottom. But I only have one term here because that's a multiplication. This is 2 terms. There's distribution here because it is a minus sign. If it's a minus or plus, that separates terms. I only have one term here, which is yx, or can I rewrite it as xy? Yeah. So let's multiply that out, and I'm now going to get x squared y squared.
So when you distributed for the top, did you just distribute the x, y? What happened to the y?
What happened to the y?
Yeah.
Are you multiplying a y? You're distributing a y, right? But I'm multiplying by a y, but what happens to this y down here?
Canceled out.
It canceled out.
On the other side, the x got canceled out?
Yep, the x got canceled out. And that's the reason why I am multiplying by common denominators, because I want to cancel out each denominator as I go. So now I have simplified this. I no longer have fraction over fraction, do I? I just now have one fraction. I have a numerator, and then I have a denominator.
And then that whole thing is like...
Yeah. Yes.
Where did you get the x squared y squared from?
All right, so when I multiply this, what is y times y?
Oh, okay.
And then x times x. Because there's a multiplication happening in between there, yeah, there's no separation. So I just multiply them together. xy times xy. Now, anyone else questions? Now this next step, it's a super simple common step. But the problem is, y'all probably never do it because you always go the other way. Common denominator means I have 2 fractions, right, with the same denominator, right? And when I rewrite them, I put them over one denominator. Yes? Okay, you could undo that. So if we know it's a common denominator, I'm going to separate my 2 fractions again. So this first part over here, I'm going to separate. So I'm going to have y squared over common denominator, which is x squared y squared. Does that make sense? Minus, because I'm right here, I'm separating my 2 fractions, x squared over x squared y squared. So this step right here, a lot of people forget that it's even a thing because you go the other way. You would have both of these here on the right-hand side and end up combining them to be over one denominator here, right? Yes?
Yes.
Okay. So in math and algebra, whatever you do, you could undo. Everything has an opposite. Multiplication, opposite division, addition, opposite subtraction, exponent, root, those things. So same thing goes here. Now, look carefully. Look at my first fraction. What can I do with that first fraction there?
Cancel out the y's.
Cancel out y squared, right? All right, what about the other side?
Cancel out x's.
Cancel out the x squareds, right? And so, what's left on top if I cancel out everything? What's left? 1. 1's going to be left. If I cancel out everything on top, there's always going to be a 1 there. Because think of it like this. Y squared divided by y squared is going to leave you 1. 5 divided by 5, 1. X divided by x, 1. So right here, I'm left with, since I canceled it out, there's always 1 there. And on the bottom, what's left over?
The x squared and the y squared.
X squared. Ah! I decided to restart. So yes, it is going to be x squared. Give it a second, come back on. There we go. All right. X squared minus 1 over y squared. If I'm proving identities, I don't need to translate them back into trig. Does that make sense? These are like puzzles. I like doing these because I invented this way of doing trigonometry. Translate everything into x's and y's, and then use algebra to solve it anyway. Instead of actually trying to use trig identities, which there is like 17 or something like that, to eventually show that you have the same thing, you could just use algebra to show everything instead. Yes?
So if we go to college and since this is in dual enrollment, we have to take another trig class, are they going to teach it differently?
Yeah. They'll teach you using the actual trig identities. But what could you do instead? You could do this. And did you prove it? Yeah. You proved it. So it's the same thing. So depending on how horrible your teacher is, I taught this to other professors. I teach at college. So I showed this. So some of the other college professors I work with do this now. So I'm hoping it ends up, growing or whatever. So, because it's easier to see it like this. All right. That being said, hopefully you guys feel pretty good about it. Verify this identity. Is this the last one?
No.
No.
There's more stuff.
We got, how many more do we got?
One more. This is this last page.
4 is the last one?
No, 5 is the last one.
5 is the last one? Okay. So, how about this? I want you guys working on the homework today. Actually get to this tomorrow. I'll do the last 2 examples. And there's also travel tomorrow. So I want you guys in here to finish this up tomorrow. So make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from my merch store.